So let's come up with the next topic, that is the simple regression. So what is a simple regression and how we interpret the coefficient? So I have some main objectives. So here we have the two main objectives, that is the first one is to establish if there is relationship between the two variables. That means if we are going to increase one variable, then there is an increase in the other variable, or if I increase one variable, then I got a decrease in the other variable. That means there is some case of directly or inversely proportional, that if I am increasing something, that means the other thing might be increased or might be decreased. So then that means that I am defining the relationship between these two variables, and this relationship is in the form of the directly proportional or in the form of the inversely proportional or in the other cases. So here we have we use the simple regression model. Linear regression model is basically to establish the relationship between the two variables. So more specifically, I can say that establish if there is a statistically significant relationship between two, or I can say the example is income and spending. So what does that mean? That means the income we have, or the money we you can say that we earn, and the spending we do. That means we buy some goods, we buy some you can say essentials of our life. So is these thing cover up our income? So what is the relationship between the incomes and the between the spending? So what income an individual have, and what his spending, and what the income he left after spending. So these all these thing, or all the information, or all the relationship between the income and spending, this is basically I can you can say explain it with the linear regression model. Or I can say that the wages and the gender. So what does that mean? That means the gender. That means if the male is earning something, so that means the female earns higher than the male. So basically here is the gender discrimination exists, so that is not a case. So basically if that case happened, then we use simple linear regression models. And further is the student height and the exam score. So this is an unusual, you can say unusual statement, that the student height affects the exam scores of the student. So that basically doesn't exist, but if that case exists, then we see the results, or we see the information based on the by using the simple linear regression models. So here we have some forecast new observation, that can we use what we know about the relationship to forecast unobserved value. So what does that mean? That means if we are going to uh, build some business, or I can say that if I'm going to sell something, so I don't know what the output we get, or is it is productive, or I got the loss, or the things like that. So that means we use or I can say that the sales will be more in the next hour, or the sale will be less in the next hour. So all this observation I can explain by using the simple linear regression models. So here as we discussed about in the previous video, where we discussed some regression, so there we discussed some dependent and the independent variable. So the dependent variable, this is the variable whose values we want to explain or forecast. That means dependent variables are those variables to which we are going to explain or to find the results, and the independent variables are that explains the other one, that explains the dependent variable, or on the basis of these independent variable I got results, or I got output in the form of the dependent variable. So basically these the values depend on something else, that values is known as dependent values, or other one is known as independent. So we know denote their dependent variable with the y, and the independent variable with the x. So here is the I can say the magic, or I can say the I can write the equation in the form of the linear equation. Like you may remember one of these are the basic linear regression, or sorry, the basic linear equation we studied earlier. Here x and y is the function of x, y is the independent y is the dependent variable and x is the independent variable, and a and b are coefficients here, and a is some constant, or I can say intercept. So in this status word, we just use a different notation. Here in statistical word, I use this you can say linear equation in the form of y, that is equals to beta naught plus beta 1 x, and here beta naught is basically the intercept and beta 1 is basically the coefficient, or I can say the slope of the x. So we call it a linear because the equation represents a straight line in a bidimensional plot. That means if I can plot this equation graphically, so I got a straight line. So then that means that this equation is a linear equation. So I am moving forward toward the example of some, you can say I can take an example of the linear equation in the form of this statistical equation. So then that means y that is equals to beta naught plus beta 1 x, and I am taking this example y that is equals to 4 plus 2x, and I plot it here. This is the x-axis, this is the y-axis, and I plot a straight line like this. That means that straight line cuts at the point 4 to that vertical axis. That straight line cut the vertical axis at point 4, as you can see on your screen, by taking, when we take x equals to 0. So this is the straight line I got, and this is the, as you can see here, this is the distance between from this horizontal line to this straight line, that is the 4 units. And if I am taking, I can say that if I am taking y equals to 0, then I got this term, that is the 2 unit, like this. So I can say that if we change a unit of x, so I got 2 times the value of the y. So that means here in this you can say in this example, I have the slope that is 2. So this is the slope here, that is the 2 units. So here if I move a step forward, or I move every unit of x, then I got the 2x, that means the double of the y. So I got the value that if I have the value of x like 2 and 4, then I got the value of y the 2 times the value of the x, then that means that is 8 and 12. So this is the case here. Next I am taking some another linear equations. So as you can see on your screen, these are 2 linear equations. The first one is y that is equals to 9 plus 2x, so I am plotting it here, and the second one is minus 2 plus 2x, that is plotting here. So this line minus 2x intercept the below the horizontal line, that means that straight line cuts the point minus 2 that is below this horizontal line. So these are the simple linear you can say the graph of the linear equation if we have linear equation of this type. So the further is that is the case where we change the intercepts, or we change the values of the beta naught. So in the next example here, I am going to change the value of the x here and fixing the value of the intercept. So here as you can see on your screen, this blue line is basically the value of this linear equation, and this white straight line represent the value of this function. As you can see here, now this line passes through the 4, but this move toward like this. So that means this line y that is equals to 4 plus 5x, this is I can say that faster than the previous linear equation. I got the faster results, and here y is 5 times the x. So that means here for every unit of x, I got the 5 times the value of the y. So next I am taking another example here. Here I have 0 x, I can say that the value of the x is 0, or the coefficient is 0. So that means I only got y equals to 4. That means this yellow line is a straight line that passes or cuts, I can say, the vertical axis at the point 4. So these are the cases here. Next I am taking the value like y that is equals to 4 minus 3x. So that means here y decreases, and the y decreases just, I can say that 3 units. That means for every unit of x there is a decrease in y 3 unit. There is a 3 unit decrease in y, or I can say that. I repeated that for every unit of x there is a decrease in 3 unit of the y. This is the case here, and more generally we didn't take this case, we only you can say explain these type of conditions here. So here that means, as you can see here, these are basically the true values. As you can see on your screen, these are the basically the values of the you can say some linear equations in the form of these dot. And this is not necessary that we got the regression line on these points. This is not necessary that these points intersect the regression line. So here we have some notation that I can explain here is in the form of the errors. So that is basically the distance between these scattered point with the line. So this is represented with the error in the form of the e, as you can show on your screens. Now further is, if I explain this linear equation or that graph, I can write it as y that is equals to beta naught plus beta 1x plus e. E is the error here. So here y is the dependent variable, x is the independent variable, beta naught is the constant, or I can say the intercept, and beta 1 is the xi slope or the coefficients, and e is epsilon is basically the error term, as I discussed earlier. These are the error terms. So when minimizing all these error, I got this straight line, or I can say the simple linear regression model. So here I'm taking some example, or I explain you give a journal overview of this whole linear regression model. So that is, we could explain a family consumption of a given product. That means we are going to explain, or we are going to take in concern of different families and check their consumption of some given product. That if I am taking the soap consumption, or I am taking another thing like the flour, or the, I can say anything. So that means the given product, and I am concerned about the family's consumption. So here I am solving this thing by using this regression model. So by taking this simple linear regression model, I can interpret this simple linear regression model according to this, you can say, example in the form of this, like that consumption that is equals to beta naught plus beta 1 income plus e. So basically this is the relationship between income and the consumption. So that means how the income depend upon the consumption, or how the income fulfill the consumption, or the consumption is more than the income. So all these information I found from this, or I can say I explained from this simple linear regression model. So the so here we will test is that income explain the consumption. So these are the things here that we discussed. This is the simple linear regression model. On the basis of this regression model, we explain different conditions, or we explain the relationship between two, or you can say other things. So in the further you can say in the further lecture, I will inshallah surely will explain to you some example, and will explain some another things which are useful for us. So if you have any question or anything, any point that disturbs you, so just throw a question, I will surely answer you. Hope you understand.